Okay, guys. So this is something that was supposed to be pretty easy. I'm getting the impression that a lot of you are working through problems and assignments very, very fast because you're not learning the material. You're copying and pasting too much. And some of you are just not even doing the work because you're just copying all the time. Well, when it comes to things like this, that is harder to copy, I can really see what level you're at. And it's a little scary to me that this was a very, very simple task that many of you really, really struggled with. So I'm going to go over this, and I want to really caution you about what's going to happen, because you know what? I think DCAs are going to change. I think we might be doing some more things like this where you really have to prove that you understand what's going on. So if you're someone who is not doing the work, you better make sure that you are, so that you're learning the material. Okay. So this is just a simple setup. You have a plant called Elodia. It's just a little water plant. It lives in the water, and lots of people have them in their aquariums. And they have it in a flask underwater, and it has this test tube inverted over top of it so that it can collect gas. And this one is 10 centimeters away from a light source. This one's an identical setup. The only difference is that it's 20 centimeters away from the light source. And this one, again, is another identical setup. The only difference is it is in pitch black dark. There's no ambient light. There's no room light. It's in complete darkness. Okay. The results of the experiment are that the students counted gas bubbles that were produced. The ones that were in setup A, where it was 10 centimeters away, gas production was 40 bubbles a minute. In B, it was 25 bubbles a minute, and in C, it was 10 bubbles a minute. So the first question then was asking you to explain what gas was being produced for setups A and B. This wasn't a, I think this is what it is, or you're guessing. You should know the answer to this, right? We just learned about all these processes that happen in plants and animals. What process do plants perform when light is around? Okay, it's a very simple question. So what gas, and then what, explain how. Okay, so it's saying identify the gas and then explain your answer. So your answer should include a gas and an explanation. So basically you're saying it's this, and I know this because X, Y, and Z. You're explaining it. Okay. For question number 2, it is looking at the difference in the gas production between A and B. So basically in A and B, setup A makes way more gas bubbles. Why is that? You look at what's different between the two of them and talk about what you think that that does to the process that's happening. So again, you should describe what you think is causing the difference between the two plants or two setups. And then question number 3 then is talking about setup number C. Setup number C, if you remember, was the one that is in complete darkness, but it still makes some bubbles. Okay. This one you guys are trying to get creative about, and you really don't need to. It's saying to identify the gas being released and explain how it is making that gas in the absence of light. Y'all, plants do not only do photosynthesis. So you don't have to try to come up with a reason how photosynthesis still happens in the light. We know that in the light reactions, light comes in. One of the byproducts of the light reactions is oxygen. If there is no light, the light reactions are not happening, period. And no oxygen is being produced. So think about all the processes that a plant does. It's not just photosynthesis. Okay. So again, what gas is being produced and why? All right. Now the drawings are where we had a lot of problems. The drawings, I feel like a lot of people just didn't read fully what you were expected to do. You are to create a model. Okay, this is not paragraphs. This is not sentences. You're drawing. You can use labels and brief descriptions, but you are not to just superimpose a whole bunch of paragraphs on top of this image. The image is there because you were supposed to draw on it. Okay, so here it says to use all necessary cell structures, so the cell organelles, chemical equations, arrows, and descriptions if needed to describe what is happening, the process that it's explaining. So this first one asks you to draw how water moves, how it is stored, and how it is released from the plant, and that is it. I shouldn't see other extraneous things. Like I shouldn't see a sun here, because what does the sun have to do with how water moves in the plant? Nothing. Okay, so it should only show me how water moves. Okay, and you're probably going to be using arrows, right? Because it goes in a certain way, goes up a certain direction, things like that. So you're going to be using arrows. How it is stored. So it's probably going to be an organelle. And then how is it released? Okay, so again, you have another organelle and you have, how that water gets out of the plant. Okay. This next one is all about how plants acquire energy. Okay. Now, a lot of people drew a sun shining on the plant and that was it. Okay. That's the kind of answer I would expect from, my sixth graders, not from pre-AP biology students, especially after we just spent a whole unit talking about the complex processes that happen at the cellular level. What organelles have we been talking about? They should be drawn here. What equations have we been talking about? Products, reactants. We talked about a lot of things that a plant has to go through in order to get chemical energy, right? And it's not just photosynthesis. Some of you did a really nice job describing how photosynthesis happens here, but that's not the only process. Even if a plant just went through that, they can't use glucose to do, remember the cell's currency. What does the plant have to do? Okay, so go back, put some effort into this major grade, because as it stood, most of you would have failed this assignment. So you're going to go back, you're going to do it, and you're going to put some effort into it, and you are going to make a better grade. Okay? All right, guys.